Hello students, now let us start with the next chapter, that is basic concept of chemistry. So we'll start with the next thing, that is first, that is law of conservation of mass. You know this thing. We have studied this in up to 10th standard. Law of conservation of mass. So Antony Lavoisier, he performed many combustion experiments like phosphorus, burning of phosphorus and Hg, that is mercury, and he found that which after burning there is an increase in the weight, and he observed that total mass of reactant, total mass of reactants equals to total mass of product, total mass of product. So he concluded that mass can neither be created nor destroyed. Mass can neither be created nor destroyed. You know this thing. Neither be created nor destroyed. But actually, this is not practically true, remember. You cannot get 100% yield of any chemical reaction. Now, the next thing, that is the next law we'll be studying, that is law of definite proportion. Law of definite proportion. Law of definite proportion. Now, one thing you always remember, that these laws were put forth in 18th or 19th century. So whatever the things we study now, how do we approach or how do we come to the conclusions? This was just the beginning of this. So you might find it very simple, but this is the way we started with the different chemical concept. So the French chemist Joseph Proust, he performed some experiments on the two samples of cupric carbonate, that is cupric carbonate, CuCO3. And it was found that the natural and synthetic percentage of different elements. In case of this cupric carbonate, what does he do? He performed some experiment by taking natural and synthetic samples. Means he found the cupric carbonate naturally, and he prepared cupric carbonate in lab also. So the percentage of copper in both the samples, percentage of oxygen in natural and the synthetic sample, and percentage of carbon in both the sample, it was found to be same. So it was 51.35. Here also it was in synthetic sample, it was 51.35 in percent. It was found to be 9.74. This is also 9.74, and this was found to be 38.91 and 38.9. So the total of these percentages should be always equal to 100. Remember. Okay. So this was the result he obtained on performing some or collecting some data on this. Whether the sample was of natural origin or it was the synthetic one. Synthetic means which is prepared in the lab. So the law of definite proportion, it can be put as this way. We'll go to the next slide. That is, a given compound, a given compound always contains, given compound always contains exactly the same proportions, exactly the same proportions of elements by weight, elements by weight. Okay, so this is the law of definite proportion, means each and every sample, it has got definite proportion of the elements by weight. Now the next, that is law of multiple proportion. Law of multiple proportion. Law of multiple proportions. When two elements So when two elements, suppose we take A and B elements, form more than one compound, more than one compound, the masses of elements, the masses of element B that combine with given mass of A, that combine with given mass of A are always in the ratio of small whole numbers. There is always a small whole number ratio, small whole number. So this sentence is important here. So now, for example, this can be explained very well by taking some example like hydrogen and oxygen. They combine to form water, isn't it? And it can also form hydrogen peroxide, that is H2O2. So how we do write the reactions for this? Now at this moment you can be easily able to write the reaction, but initially when uh, this French chemist, he just tried to combine this hydrogen and oxygen together. So he took 2 grams of hydrogen and oxygen needed for the formation of water molecule. It was found to be 16 grams and 18 gram of water was found. Okay. Similarly, hydrogen, when it was taken as 2 grams and oxygen as 32 grams, then 34 grams of hydrogen peroxide was found. Hydrogen peroxide. Okay. So in above examples of the reaction, the two masses of oxygen, that is in this reaction, in this particular formation of water, 16 grams of oxygen was taken. In formation of H2O2, 32 grams of oxygen was taken. And it was reacting with the fixed gram of hydrogen. So the weight of hydrogen that you are taking, it is same in both the reactions or both the products formation, that is hydrogen peroxide or water molecule. So this percent or the grams of this hydrogen, it was found to be same here, that is 2 grams. Okay, so the fixed masses of hydrogen was taken. So I'll try to be on the same slide, so I'll write somewhere here. So the 2 grams of hydrogen, and there is change in the weights of this oxygen here. It was 16 gram and it was taken as 32 gram. So it was found to be the ratio 16 is to 32. So the ratio of this whole numbers, you can write 16. This is what is this 1632? This is the grams of oxygen here. Grams of hydrogen, it was found to be same. That is 2 grams. So this is in the ratio of 1:2. Isn't it? So here the small whole number ratio, it was related to this weights of this oxygen here. Remember this hydrogen, we are keeping this as the same. Now the same law can be explained by taking another example like combination of nitrogen and oxygen. Nitrogen plus oxygen, it is forming nitric oxide. Nitric oxide. So when this nitric oxide is formed, 14 gram of nitrogen and 16 gram of oxygen, and it forms 30 grams of nitric oxide. Nitric oxide means NO, molecular formula. And another product, by combining these same two elements, that is nitrogen and oxygen, with different weights. Of course, this weight of oxygen should be same here, 14 grams of nitrogen plus 32 grams of oxygen. When they combine together, it forms nitrogen dioxide. Nitrogen dioxide. Okay. Means NO2. So 46 grams of nitrogen dioxide form. So here again the ratio of this 16 gram and 32 grams. So again it is in the ratio of oxygen is this ratio it is of oxygen. Remember this is ratio of oxygen 16 is to 32 means that is 1 is to 2 ratio. Now another example you can put like this formation of carbon monoxide and carbon dioxide also, where the mass of carbon is fixed here. Mass of carbon, it is fixed. And it is in the ratio, here there is only one oxygen, there are two oxygen. So of course it will be in the ratio of 1 is to 2. Similarly, you can write for SO2 and SO3 also, where there are 32, O2 means 2 oxygen atoms is 32 gram, 3 oxygen atoms is 48 gram. So the mass of sulfur here it is fixed. Mass of sulfur is fixed here. And mass of oxygen it was going to be 32 to 48. 32 is to 48. So the ratio would be that is 2 is to 3. Okay. So this is very much related to mass of oxygen. So this is what we call as the law of multiple proportions. Remember, this the elements which are reacting together, those are same, nitrogen and oxygen, but they are forming two different molecules of the compounds, and the ratio of these two oxygen, the nitrogen, the mass of nitrogen is fixed, and mass of oxygen, if you change, you are getting here different products, and this ratio is always a whole number ratio. So that is what we call as the mass of law of multiple proportion. Now, in the next lecture, we will talk about the Gay-Lussac's law of gaseous volume.